Hello everybody. So today we're discussing differential equation notes. From these notes, this is by Nishant Vora sir, from his bounce back series. And from these notes, I can guarantee you that you will be able to solve 90% of JEE Mains PYQs, and it will set a very good base for you. Speaking from personal experience. So the first type is dy by dx is equals to f of ax plus by plus c. Basically, if you see any repeated linear factor, like this is a good example, like y plus 3x you see it repeating twice, you put that as t and see if it helps. If it helps, you would notice that dy by dx plus 3 becomes dt by dx. So from there it's easier for you to solve the question. There is a JEE Main 2024 PYQ about this in January. Reducible variable separable. So basically dy by dx is equals to linear by linear is given to you. And here, if the coefficient, y coefficient of numerator, sum of that with x coefficient of denominator is 0, then you just cross multiply. The logic behind this is if this plus this 2 plus 2, sorry, 2 minus 2 is 0, then when you cross multiply, you get 2 into x dy plus y dx, which is d of x y, and the rest of the terms are grouped, like none of them has y dx term in it, so the differential equation is solved. You can take a look at the example. Okay, reducible variable separable of another type. Basically, sir said that this is not a very asked type, but I'm still, I wrote it down, so I'll tell you guys. If you ever see x dx plus y dy is equals to r dr type of differential equation, or this type, sir said that we should substitute x equals r cos theta and y equals r sin theta. And in the end, when we need the values for r can be substituted with root over x square plus y square, and tan x can be substituted with y by tan theta can be substituted with y by x. The same goes for this type also. I'll just pause so you can look at it, and this is an example that you can solve. Perfect. So the next is a homogeneous differential equation. The way to identify this is if the degree of every single term there is the same. So replace x and y with lambda x and lambda y, and if the lambda comes out with the degree. So basically, if the homogeneous equation is of second degree, then lambda square would come out. And here it's a simple substitution. Y will be substituted with vx, or in some cases x will be substituted with vy. So yeah, this is a question that we can try. You can solve it. Just I'll pause for you to take a screenshot. There you go. Convertible to homogeneous. So this is not homogeneous, but we can convert it into homogeneous. Here this plus this is not 0. In this case, we take x is equals to capital X plus some h, and y is equals to capital Y plus some constant. Here this is still variable, but this is a constant, this is still variable, and this is a constant. So basically we choose the constants in such a way that this c is eliminated, so we can easily differentiate it, solve the differential equation. Linear differential equations, I will be making a separate video on how to solve reducible to convertible to homogeneous reducible equations, so stay tuned for that. This example will be solved there. Linear differential equations can be identified if you know the dependent variable, basically y, and dy by dx terms are not multiplied together basically. And another important thing is the dy by dx should always have a power 1, never power 1 by 2, or you know power square. That shouldn't exist. So these are a few examples of what's a linear differentiable equation and what's not. You can take a look at it. The general solution for this is to take the x function that is multiplied with the y as integrating factor. So you integrate it in the e powers. So e power p of x dx, and the form is like this. Y into e power integral p dx is equals to integral q of x into integral p dx. You can take a look at this example. And you can also solve this question. I will solve it in another video. So another basically standard form, the same but with dx by dy instead of dy by dx. And yeah, those are some examples that I've just solved. Yeah, so that is about it. I would highly recommend that you once just watch Sir's class if you're heavily weak in differential equations. This is just for people who are, you know, little unable to solve the questions, but you have no idea about the concept. I would definitely recommend that you watch Sir's class first. So exact differential, Sir said that we could learn some of these so that it becomes easier for us to solve the calculations later on. I will be